Hello everyone, welcome. In this video, let us solve this question. So we have 2 power of t is equal to t power of 32. And here, we to solve for the value of t that satisfy this given equation. Now to do this, solution, we have 2 power of t is equal to t raised to power 32. Okay, to solve this, first we're going to eliminate this t right here. Now to eliminate this t, we multiply both sides by power 1 over t. So we're going to have 2 raised to power t, then multiplied by power 1 over t is equal to, here also, t raised to power 32, or multiplied by power 1 over t. So if you have a raised to power n times m, this equals, in brackets, a raised to power n power of m. Or if you also have a raised to power n power of m, this equals a raised to power n times m. So applying this rule to this, power t here will multiply power 1 over t. You have 2 raised to power t over t is equal to, here also, t raised to power 32 here will multiply power 1 over t. You have 32 over t. With this, 2 will divide t, you have 2 raised to power 1, which equals 2, is equal to t raised to power 32 over t. So with this, we are then going to eliminate this power 1 over t by multiplying both sides by 1 over 32. So from here, we have it that 2 raised to power 1 over 32 is equal to t raised to power 32 over t, all multiplied by 1 over 32. So also applying the same principle to this becomes 2 raised to power 1 over 32 is equal to, now 32 times 1 is, okay, you have t, then 32 times 1 is power 32, then all over 32 times t is 32t. From here, we have it that 2 raised to power 1 over 32 is equal to t, then 32 comes to 32, you have 1 over t. Okay, at this junction, as you can see, t here is equal to the denominator power, which is also t. So we're going to ensure that what you have right here is equal to the power denominator, what you have right here. But in this case, 2 here is not equal to 2 here, right? So they are different. So we're going to ensure that what you have right here is equal to the power denominator of what you have right here. And to do this, we're going to make use of what is called equivalent fraction. And what do I mean by equivalent fraction? Now let's say you have 1 over 2. Now 1 over 2 can be written as 2 over 4. Because 2 will divide 1, 2 will divide 4, you have same thing as 1 over 2, right? Same thing also if you have 1 over 2, it can be written as 4 over 8, right? Because 4 will divide 1, 4 will divide 8, you have 2. So in this case, we will replace that fraction with another fraction that will still give us that same fraction. So that's what we're going to do to this, okay, to make what you have right here to equal the denominator power of what we have right here. Now to do this, we have 2 raised to power 1 over 32 is equal to t, all raised to power 1 over t. Now, 1 over 32 can be written as 2 over 64, right? So then 2 raised to power 2 over 64 is then equal to t raised to power 1 over t. Now, if we factorize out 2 from here, we have 2 raised to power 2 times 1 over 64 is equal to t raised to power 1 over t. Also, applying the same principle, that if you have a raised to power n times m is equal to a raised to power in bracket m, then power of m. So applying this right here, we're going to have in bracket 2 raised to power 2 all raised to power 1 over 64, which equals t, then all raised to power 1 over t. Now in this form here, 2 squared is 4, so we have it as 4 raised to power 1 over 64 is equal to t raised to power 1 over t. So as you can see, what we have right here is not also equal to what we have right here. So we are still going to continue further until what you have right here equals the denominator power of what you have right here. Same thing as what you have as here also. So to then do this, we also replace this 1 over 64 with another equivalent fraction. Now, 1 over 64 can be written 1 over 64 can be written as 2 over 128, because 2 will divide 128, you have 1 over 64 back. So therefore 4 raised to power, with this now you have 2 over 128 is equal to this t raised to power 1 over t. Also, factorize out 2 from here. 4 raised to power 2 times 1 over 128 is equal to t all raised to power 1 over t. With this, applying the same principle, that if you have a raised to power n times m is equal to, in bracket, a raised to power m, then power of m. Applying it right here, this then becomes 4 raised to power 2 all raised to power 1 over 128 is then equal to t raised to power 1 over t. Now, 4 squared is 16, all raised to power 1 over 128 is equal to t raised to power 1 over t. Okay, with this, we have it as 16, all raised to power 1 over 128 is equal to t, all raised to power 1 over t. But take note of something, this 16 right here is not equal to the power denominator, which is 16. Here we have 128, so we are still going to continue further to break it down until what you have right here equals the denominator power of what you have right here. So let us continue by working with the equivalent fraction. Now, the equivalent fraction of 1 over 128 is equal to 2 over 256, right? Because 2 will divide 256, you have 1 over 128 back. So in place of this, we'll put in 2 over 256. So we have it as 16 all raised to power 2 over 256 is then equal to, we have t raised to power 1 over t. With this, if we factorize out 2, we have 16, then bringing out 2, we have 2 times 1 over 256, right, is then equal to t all raised to power 1 over t, right? So from here, applying the same principle, this one, that if you have a raised to power n times m is equals to a raised to power n, then all power of m. So applying it right here, we have in bracket 16 all raised to power 2, then all power of 1 over 256 is equal to t all raised to power 1 over t. From here, 16 squared is 256 all raised to power 1 over 256 is then equal to t all raised to power 1 over t. Now, as you can see, we've gotten it, that what you have right here is equal to what we have right here. With this, we can then bring in one principle, that if you have a raised to power b, which equals a raised to power c, right, we can then compare the exponents such that b is then equal to c. So applying this principle to this, right, 1 over 256 can be equal to 1 over t. So therefore, 1 over 256 is equal to 1 over t. With this, we can then cross multiply, shows that t times 1 is equal to t, which equals 1 times 256 is 256. And with this, we've gotten the value of t as 256. Now let us check if this value of t as 256, if we input it back into the equation, can it satisfy this given equation? Okay, so we have 2 all raised to power t is equal to t all raised to power 32. Okay, from here we have it that 2 power of t is 256, so power of 256 is equal to t is 256, so in brackets 256 all raised to power 32. Okay, so we have 2 raised to power 256 is equal to, now 256 can be written as 2 raised to power 8. Okay, 2 in 8 places will give us 256, then power of 32. Also, applying this same principle, if you have a raised to power n, all power of m, this equals a raised to power n times m. So with this, 2 raised to power 256 is equal to 2 raised to power 8 times 32 is equal to 256. So as you can see, what you have, the value of t that we got, okay, satisfy this given equation, right? I hope you all enjoyed the video. Don't forget to like the video, subscribe to this channel, okay? Share this video to your friend. See you in the next video. Thank you very much.